in 4.9 here, we are going back to graphing inequalities. Yet this time, we are dealing with quadratic inequalities. So, putting it all together, a lot of the same principles still apply to both of, the quadratic inequalities as well as the linear inequalities that we did a couple chapters ago. So to graph a quadratic inequality, graph the parabola, okay? If it's less than or equal to, so if it's less than or greater than, you have a dashed line. If it is less than or equal to or greater than or equal to, then you would use a solid line. You pick a point to test to determine which way you would shade within your quadratic. Shade the side that includes the solution. If it is a system of quadratic inequalities, then you would graph them both on the same plane, test points for both, and shade a region accordingly. Essentially, all of the same principles still apply. The only thing you need to do different in this case is now you're graphing a quadratic. So I'm going to probably just pick 2 or 3 of these to graph. And from there, I'm going to let you guys try them on your own, and then we'll look at them during class together. So let's pick number 1, since it is the easiest. So number 1, we are dealing with vertex form. So before we even get started, let's check your inequality symbol. This indicates that we will have a dashed line. Okay, since we are in vertex form, we can find the vertex right away. Remember, you take the opposite of the value inside the parenthesis as your x value, and then you take exactly what it says as your y value outside of your parentheses. So right away here, our vertex is going to be +2, -3. That acts as our vertex, our x values and our y values here. So let's go ahead and graph a couple more points. So if I have 1, 0, -1, if I also go the positive direction, remember on both sides of your vertex, you will get the same solution. So if I was to plug in 1, or substitute in 1, I have 1 minus 2, which would be 1 squared, 1 minus 3, -2. That's the same on both sides. For 0, -2 squared, which is 4, minus 3. Gives me +1 on both sides. For -1, we got 9 minus 3, which is a +6. Both sides. So let's go ahead and graph our quadratic. We're going to go over 2 minus 3. And that marks our vertex. Then we've got -2 on both sides. Then we've got +1, 5, 6. And from there, we have graphed our quadratic, which you guys already have a little bit of practice doing. Okay, so from here, we have to go ahead and test a point. So we might as well test 0, 0. In this case, 0, 0 is on the outside of our quadratic. So testing 0, 0, we've got 0 is less than 0 minus 2 squared minus 3. So that gives us 0 is less than -2 squared, which is 4, minus 3, which gives me +1. So is 0 less than +1? That is a true statement. Let's try that again. A true statement. So that indicates that we are going to shade on the outside of our quadratic. So shading, you are going to have something like that. Okay, so really, as you guys can tell, same exact process. Oh gosh, I even messed up though. As you guys can tell, same exact process as when you are graphing linear inequalities, yet this time you just have to graph a quadratic. So the thing that I messed up on was I need to have a dashed line. That is why that is the first thing I looked at. Luckily, I wrote it down, so I was able to catch my mistake. So really, I think that is a good lesson. It's the first thing we should look at. All right. So let's actually let's go through and do number 2 together, and we'll save 3 and 4 in class. So for number 2, as you guys can tell, we aren't necessarily in standard form because we don't have a b value. We aren't in intercept form, and we aren't in vertex form. Okay, so in this case, we need to go ahead and convert it to one of our forms. So an easy form to convert this to would be your vertex form, because I've got y is greater than or equal to. If I want this in vertex form, I just need to figure out what the number on the inside of my parentheses would be. In this case, I've got 2 times, I've got x squared. So if I've just got x squared, that's the same as saying x minus 0 squared minus 9. So now at this point, I have converted this to vertex form. So let's go ahead and look at our symbol. We have a greater than or equal to symbol. So that means that I'm going to have a solid parabola. Finding our vertex, we take the value inside our parenthesis, which is 0, and the value outside, which is negative 9. And that right there is our vertex. Take a couple points on both sides. Negative 1, negative 2, negative 3. 1, 2, and 3. And let's plug them into our equation. So negative 1 minus 0, negative 1 squared. That will give me negative 7. For negative 2, negative 2 minus 0, so that'd be 4. 8 minus 9, negative 1. And then for 3, 9, 18 minus 9, which is a positive 9. So from here, let's go ahead and graph our quadratic. We've got 0, negative 9. All the way down here. Negative 7. Negative 1. And then a positive 9. So go ahead and draw in your parabola. This is a very narrow parabola since we have our 2 out in front. And then let's go ahead and test a point. So let's go ahead, keep it the same. Let's test 0, 0 because it's right in the middle of our parabola. So testing 0, 0. You can test this with either of your 2 equations. They are identical. So 0 is less than or equal to 2 times 0 squared minus 9. 0 times anything 0, so that gives me 0 is greater than or equal to negative 9. And yes, that is a true statement. So that will result in us shading the inside region of our parabola that contains 0, 0. So in order to keep this video pretty short, actually, let's do 3 and 4 on your own. So for 3, you'll have to start by finding your vertex using your axis of symmetry formula, and then graph and test a point. For number 4, you have a vertex form and a standard form. Graph them both on the same coordinate plane, and then test a value to see where they both are true at the same time. Okay, please try these on your own. This will be what we start class with. All right, thanks for watching.